let me ask you this. Everything that you're saying there, to be clear, we're not abandoning our existing models about how galaxies form and evolve yet, right? Well, we might have to. Yeah, but that's okay. That's not a bad day. That's a great day for science. The James Webb Telescope's recent discoveries could upend our understanding of the universe's origin. These findings are increasingly challenging the held theory about how the universe began. But recently, James Webb Telescope has captured a glimpse of the early moments of our universe, and what it saw was astonishing. As you may know, the massive early galaxies observed by the Webb telescope have been a major puzzle for astronomers. There are some controversies about the existence of these strange galaxies, and scientists currently do not have a sufficient explanation for these enormous and mature galaxies. Adding to the ongoing crisis in cosmology, the James Webb Telescope has discovered something very unusual in the early universe. Scientists are now suggesting that the early universe was not like ours. It was a different universe with slightly different physical laws. These claims are not made randomly. Scientists have found evidence supporting the idea that the early universe was not the same as our current one. Scientists say all our predictions about the beginning of our universe may be wrong. It says that the universe has an ancestor which is another universe. Consider this. According to our standard cosmological model, the universe as we know it came into existence about 14 billion years ago. Before that, there was nothing. The Big Bang is defined as the singularity, the moment in time when the scale factor goes to zero. You might think of the Big Bang singularity as a specific point in space. However, it's not a point or a unique event that happened at a particular location in space. This would only be true if the universe were finite. But if the universe is infinite, as it appears to be, the singularity isn't just a point in space. It's a point that covers all of space and has always been infinite. Also, we know that the universe is expanding from the beginning, but there is no center point of this expansion. Instead, the expansion is taking place everywhere in the universe. It's hard to imagine what this expansion looks like, but if you were to stand anywhere in space, you would see everything moving away from you. It seems as if every point in space acts like the center of the universe. Therefore, the Big Bang didn't occur in just one place. It happened everywhere. This means the first galaxies formed throughout the entire universe. It's as if matter came into existence everywhere in the universe at a specific time, which is why we see the cosmic microwave background radiation throughout the universe. So from all these theories, we came to know that the Big Bang gave birth to all the matter in the universe. But here, another big question arises. What happened before the Big Bang? Some physicists say that inflation happened before the Big Bang. As an example, in the primordial density perturbation by life and little, they define the Big Bang as the beginning of the era of attractive gravity after inflation. However, modern cosmology by Dolan defines the Big Bang as coming before inflation. Furthermore, several recent discoveries in the early universe suggest that the Big Bang may not have been the beginning of our universe, because astronomers using the James Webb Telescope have found distant galaxies that seem older than the Big Bang within our standard understanding of the universe's beginnings. All these findings suggest that something strange happened before the Big Bang. On the other hand, a new shocking discovery from the Webb telescope hinted that a strange universe existed before the Big Bang. But why are scientists saying this? Recently, scientists have discovered that the fundamental laws of physics that explain the nearby universe so well appear to have been a bit different in the universe's early days. A new study published in the peer-reviewed Journal of Cosmology and Astroparticle Physics suggests that gravity becomes about 1% weaker at very large scales. The research team was combing through data of the cosmic microwave background when they discovered this apparent glitch. The cosmic microwave background is a vast expanse of lingering radiation that was left behind by the Big Bang. Scientists use it to understand the earliest stages of the universe, like how the first galaxies formed and what happened immediately after the Big Bang. Robin W., a recent University of Waterloo graduate, and his colleagues used a model based on fundamental physical laws, like Einstein's theory of general relativity, and compared their model's prediction of what the CMB data should look like with observational CMB data. Their scientific model didn't match the observations of what they actually see in the distant universe. However, when they tweaked Einstein's theory to account for a 1% gravity deficit, their model aligned more closely with the observational data. A 1% adjustment may not sound like a big deal, but it's enough to suggest that Einstein's theory may need a rethink. What's more, this glitch suggests that the laws of physics in the early universe may be different from those in our nearby universe. Well, scientists have found more evidence that supports the idea that the universe does not follow the same laws of physics everywhere. One major piece of evidence is called the Hubble tension. Recent observations of distant Cepheid variable stars suggest that the universe is expanding at different rates in different directions. The Hubble tension refers to conflicting measurements of the expansion rate of the universe. According to our standard model of physics, the expansion rate of the universe should be the same everywhere. However, observations of the nearby universe suggest that the expansion rate is faster than regions of the distant universe. Astronomers have proposed multiple possible explanations, but haven't settled on one yet. Furthermore, scientists have found a big clue supporting this idea that the universe is expanding differently right now than it did billions of years ago. Scientists recently found a big clue about the dark energy that is responsible for the expansion of our universe. The standard model of cosmology says that the strength of dark energy should be constant, but tentative hints are emerging that it may have weakened recently. The largest 3D map of the universe ever created is providing hints about the evolution of the cosmos, and they suggest that we may be wrong about the behavior of dark energy, which makes up most of the universe. It seems that this mysterious force may be weakening over time. Adam Rees at Johns Hopkins University in Maryland, who found the first evidence for dark energy 25 years ago, says, "If it holds up, this is a very big deal." Apart from this, the Webb telescope has found supermassive black holes that formed just a few million years after the Big Bang. Scientists are puzzled because black holes this large shouldn't have been able to form so early in the universe's history through the usual process of stars collapsing. One possible explanation is that these black holes might have formed from massive clouds of gas collapsing directly. However, if this theory doesn't hold up, scientists will have to find a new way to explain how these giant black holes came into existence. All these findings suggest that our current understanding of the early universe is limited by the basic laws of physics we know. It's possible that the unusual, mature, and massive galaxies we observe from the early universe might actually exist in a different universe with its own unique set of physical laws. This raises the possibility that the theory predicting the universe had a single beginning might be incorrect. There could be galaxies and stars beyond what we consider the first ones, potentially indicating the presence of a completely separate universe with different laws of physics.